Okay, these are some problems from section 9.2. This is number 22, and this is a pretty standard type problem where they give you the derivatives, different degrees of the derivatives or different orders, and then you just have to construct the series. So you're told that f of 0 is 4, f prime of 0 is 5, f double prime of 0 is -8, and f triple prime of 0 is 6. So that's a lot of the work is taking the derivatives. So they give you that just to make sure you understand the Taylor form. So they want you to find A, write the third degree Taylor polynomial for f at 0, and use it to approximate f of 2.2. So this is from this information, everything else is our standard Taylor formula. 0, 0 factorial, 1, 1 factorial, 2, second derivative, 2, 2 factorial, third derivative, 3, 3 factorial. So we put these values in for the derivatives, and then everything else is standard, and this is about 0 at x equals 0, so it's actually a Maclaurin series. And then we can simplify it, so this is the third degree polynomial. Then we can use it to approximate f of 0.0 just by putting 0.0 in, so p of 0.0. So every time you see an x, you just put a 0.2. So we want to find f of 0.2, so we're going to use p of 0.2 as an approximation. So every time you see an x, you just put a 0.2, and then if you work it out, there's your answer. And then the B part, write the second order Taylor polynomial for f prime, a second order, and use it to approximate f prime of 0.2. So the second order, well, this is the third, so when we take the derivative, that's going to get us our second order because we're going to reduce by 1. So the derivative of this is f prime of x, which equals f prime of p sub 3, that's our approximation. So the derivative of that 0, that's 5, that's minus 8x, and this is plus 3x cubed. And again, you just put 0.2 every time you see an x, and you get your approximation. Okay, so if that makes sense, hope you can see that. Okay, 23, the same type of problem. We have our f1 is 4, f prime of 1 is -1, f double prime of 1 is 3, and f double prime of 1 is 2. And this is going to be a Taylor, and it won't be a Maclaurin because it's going to be around x equals 1. So that's why we have our derivatives at 1. Let's move this up so you can see all this here. So this is 23. And that's what we've got here. Okay. So f prime of 1, and then again this is the standard Taylor, but it's about x minus 1, or it's about 1, so it's x minus 1. Remember, in the general form, it's x minus a. So you can see the substitution right here is just out of our Taylor's formula. Okay, and then we put our values of our derivatives in. There's your 4, there's your -1, there's your 3, and there's your 2, and everything else is as Taylor states. And then the p of 3 is just, we can simplify it. This is 3/2, this is 1/3. All right, and then we go on here, and then so there's your p of 3, just given by that information, and just use Taylor. So I think that's pretty straightforward. Take a look at that. Okay, and then we want to use it to approximate f of 1.2. So we put 1.2 in here. So every time I see an x, I put a 1.2. And when I subtract 1.2 minus 1, I'm going to get 0.2 in all these. 0.2 squared, 0.2 to the third. Then we simplify this, and you can simplify it. And you probably wouldn't even need a calculator. You could probably work that out on a sheet of paper. So this could be a non-calculator problem. And then letter B. I'll write the second order Taylor polynomial just like in the previous problem, except this is about 1 rather than about 0 for a different function, of course, but a different center also. So if we take the derivative of this is going to be 0. That's going to be just -1. Where am I? Here we go. Yeah, this would be 0. This would be -1, and this would be 2 times 3/2 is 3 times x minus 1 to the first, and then 3 times that would be just 1 x minus 1 squared. So there's the derivative. Then we use that to evaluate f prime add 1.2. Okay? And there's a substitution. So every time we see an x, we put a 1.2, and that just becomes 0.2 squared, and there's your solution. So hopefully that's straightforward. You can follow all that. You can always pause these. You can always zoom in if you can't, make it out. Okay? So that's 22 and 23.